about the delay today. I usually start at 12 noon, as everyone knows, but I had to go into school this morning and I had to do a bunch of stuff at school. So I was late in starting the live feed, but hopefully everyone's here now. And good. Looks like it's brightened up a bit. So, well, I am going to, what we started this week is or last week we started the laws of sines and cosines. This week we were doing the cosine law. And then yesterday we started lesson 4, which are the big deal, right? The word problems. So we did applications of sine and cosine. And that means there's 2 things going on here, right? It's converting our learning. Hi, Cynthia. Morning. Sorry for my delay. The 2 things are going on here. We're actually applying our knowledge, which is putting math to words, right? And then also the big thing is deciding each question that comes around, we have to decide whether it's a sine or cosine. So you've got some big decisions to make in this assignment when we finally get to the assignment. You always will be provided a diagram. It would be much harder if they didn't supply the diagram and you had to make the diagram. But we've got the diagram and all the pictures. So what you have to do is read the question, figure out what they're asking you to do, right, where the unknown is. Now you can see that if I just flip back to yesterday's 2 questions had the x given and the theta given. Now in the following questions, that's not always going to happen. It's not going to be the x or the theta. So that's one other thing that you're going to have to decide what the x and the theta are. So that's another thing. Okay? So let's take a look at example 5. My goal is to try and get through all the examples and then give you tomorrow's class to work on them. And what I'll do tomorrow is class. Okay. The big decision was you have to decide whether it's a law of sine or cosine. And also you're going to have to decide what you're solving for. In examples 5, 6, 7, and 8, the ones we're doing today, they don't write an x or a theta in the picture. So you're going to have to decide what you're supposed to solve for. And also, are you using law of sines and cosines? So that's a big thing. What I think tomorrow, because I know this is a tough assignment coming up, tomorrow I'm going to make it just a work class. And instead of live directly, we could actually see each other. And if you don't choose to have the video display, you can just talk to me. So we'll see how that works for a work class, right? Something a little different. So getting back to example 5, the Luxor Hotel in Las Vegas is shaped like a pyramid with a bright light beacon shooting out from the top. So here's the light shooting up to the sky. Cynthia, oh, here you go, Cynthia. There's a question for you. Cynthia is a contractor who wants to bid on a contract washing the exterior of the building. She needs to know the length from the tip of the pyramid. Okay, this is the pyramid, right? From the tip of the pyramid to a point on the base. Okay, so here's the base, right? The angle of elevation from Cynthia to the top of the pyramid is 20 degrees. Okay, so here's where Cynthia is. That might be, I always kind of label a little more if they don't. Here's where Cynthia's standing. Because it says she needs to know the length from the tip of the pyramid to a point on the base. The angle of elevation from Cynthia to the top is 20, right? So this is where Cynthia is. The angle from Cynthia to the top is 20. She is standing at a point 250 from the base of the pyramid, okay? So this is the base, right? Base is always, when they talk about base, they're talking about the bottom of something. I just read your comment, Cynthia. The base is the bottom. That's where the term basement comes from, right? So the base is the bottom of the pyramid. She's standing at a point 250 from the base. The outer wall of the pyramid makes an angle of 35 degrees with the ground. Okay. Calculate the length of the exterior wall of the pyramid. Okay, well, this is the exterior wall, right? The outer wall, the exterior wall. So this is what we're solving for. That's the vision. So I'm solving for x. Okay. Now, what do they give me here? I've got 2 triangles, this triangle and this triangle, right? Unfortunately, I don't know much about this triangle, do I? The only thing I know is that it's 35 degrees, so I have hardly any info from this triangle. So I think I have more info on this triangle, right? I'm just going to shade it in really lightly with my pencil. Okay. So this is the triangle that I think I'm going to use. I guess I'll shade it a little darker. Okay. Again, I have two triangles. I need to find this side. This side is part of each one of these triangles, but I'm only going to use one of the triangles to solve my problem. Again, I don't have any information about this triangle except one angle measure. I know a lot more about this triangle. So I'm going to use this triangle, and I'm actually going to, and I don't know if this makes sense to you, I'm going to redraw it. To me, that kind of clears up a little bit, right? An X. If I redraw it, I can see that I have a little more info than I might have thought, right? I have this side and its angle. Unfortunately, it's not a full partnership though, right? Then I have this side. I don't have this angle. I don't know either of these, but I do know the 35 degrees, right? And that might help me out a little bit. So I'm going to highlight this 35 degrees because I can see that this 35 degrees is part of a straight angle. And remember we learned yesterday, if I just flip back, these are called supplementary angles. And if I know one angle, if there's a straight line drawn and I know part of the angle of the straight line, the other is just the 180 minus. So here's where that supplementary angle thing came in. This angle here would be 180, take away 35. Okay, so that's why they gave us all that info about, so it's 145. Okay, so this is 145 degrees. Okay, so does that help me out a lot? Let's see, these two guys are partners, right? He doesn't have a partner. He doesn't have a partner, but I could find the third angle, right? So I'm going to use this in red, right? The third angle would be using my 180 rule, because 180, it's also the degrees of a straight line, but it's also, I'm left with 15 degrees. So perfect. I know this angle measure, right? I finally, after partners, 250 partners with sine of 15. And then the side I'm looking for, partners with sine of 20. Okay, so that was a lot of work and a lot of remembering to get to that point. Once again, oops, smooth this over a bit. I had to remember that a straight line, when I cut a straight line, like draw a line through a straight line, it creates angles. The two angles add up to 180, so that let me find the 145. Then I also had to remember the 180 triangle rule. If I know two of the angles, I should know the third. That gave me my 15, and that created partnerships for me. So now I just have to do I multiply these guys, divide by that to give me what X is. So X equals 250 times sine 120, or sine 20, sorry, divided by sine 15. So 250 times sine 20 divided by sine 15. And that gives me 330.37 feet. Okay. So this is going to be, I think, probably a really good example to have in your notes because it kind of had a little bit of everything in it, right? And going back to this question, when I was looking for, at the very beginning, when I was trying to figure out what I was supposed to be solving for, I knew this wasn't a law of cosines question, right? Because it wasn't side, 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 it wasn't side, angle, side. To use law of cosines, you have to know at least two of the side lengths, right? I only knew one side length, so it's not law of cosines, it's law of sines. All right, so that was a very complex example. You can see how the level of difficulty is getting greater and greater as we move through this unit. Let's try example 6. This is a kite, like the kind of kite that you fly in the sky, but it's also a kite as a type of polygram as well. The kite shown in the diagram below is going to be made out of fabric. The person cutting the fabric needs to know the length of the short end of the kite, side AC. So this is the side we want to know, right? I'm just going to try. Sorry, my chair's really squeaking today. We want to find this length, right? So that's my X. Determine the side AC, determine X given that AD equals 80. Okay, let's see. A to D. This almost looks like it's the same height, right? This to this is 80. This is 65. And angle BDC is 40. Have vertically, then that means that each one of these has to be 20 degrees, right? 20 and 20. So I have two triangles here, right? And I know that these two are the same lengths, that's for sure. But what I'm going to do again is I'm just going to redraw the triangle I'm using. Now, they needed to draw the two triangles for us. We could get the measure of this angle down here. But really, to solve the problem, I only need one of the triangles drawn, right? Because I'm just trying to find this side here. So this is 80 centimeters. This is 65 centimeters. I've got one angle, two sides. I'm trying to find a third side. Is this law of sines or cosines? For it to be law of cosines, I need to know at least two of the sides, and I do. I know two of the side lengths and the angle between. So this is a law of cosines. And for me, redrawing the triangle and kind of separating it out from the more difficult picture, that helps me a lot figuring out what triangle law to use. So I'm trying to solve for X. So I know I've used the law of cosines many times. X squared equals, okay, these two sides squared, right? It doesn't matter who you call B and C. So if you want to call him B and him C, I guess he would be called C, right? But for my formula, I'm just going to call him B, him C. 80 squared plus 65 squared minus 2 times 80 times 65 times cos of 20 degrees. Okay. Maybe so people don't, maybe I will call him, I'll flip these guys around. Even if I call him C and him B, I don't have to change the order at all in the question because order doesn't matter in adding and subtracting. Okay, so X squared equals, so I have to put all this into my calculator. This is a big long one to put into your calculator, right? 80 squared plus 65 squared minus 2 times 80 times 65 times cos 20 equals, okay, so you get this big, huge number, 10403.919 ... And in the end, we have to square root, right? Because I don't want X squared. So I square root. Now in my calculator, and again, you've been practicing this with your own calculator, I just leave this number in my calculator and then I just press the square root button, which I have to go second square root, and then I get this answer. So X equals 101. Now, remember your rounding, 0.9999. If I round to 2 decimals, that's going to bump that up. So I guess actually it's going to be 102. It's 102 centimeters. So let me know if there are any questions, right? You can just hop on and live chat if you need to. So again, I always post my notes too, so you might want to go back and look at these notes later or review the video if you want back up, but I guess nothing is popping up on live chat, so I'm going to move on. So we've done a law of sines, we've done a law of cosines. Let's look at example balcony. So there's your friend. They spot you on the ground. Okay, so this is you. At an angle of depression of 72 degrees. If your friend is 30 meters from the ground, determine the distance that you are standing from the base of the building. So if your friend is 30 meters from the ground, so here's the triangle, 30 meters, determine the distance you are, so here's my x, right? Now, angles of depression, if your friend is looking down on you at an angle of 72 degrees, okay? That means that you're looking up, right? Because it's the same line. Can you see the same line? So the angle of elevation is also 72 degrees. Okay, so just remember that. If they give you an angle of depression, it's the same as your angle of elevation looking up. So I got a question from the previous. I'm just going to move back for a sec. Make sure your calculator's in degree mode, Cynthia, not radian. And I'll come back and help you with your calculator after the lesson. Okay, so just stay on the line and I'll help you. So remember, if your friend is looking down at you at an angle of 72, that means you're looking up them at an angle of 72. So this is a right angle triangle, right? This is 90 degrees. This is a right angle triangle. So we use SOHCAHTOA, right? To solve what you learned in grade 11, right? You learned 11, okay, or essential 30S. Okay, so make sure you're in degrees, not radians, and then I'll, okay, let's see. Do you remember the grade 11 trig? It might be a little difficult to remember, but I have this is my angle. So this would be my opposite side, opposite, and this would be my adjacent. So that tells me I have to use tan. Tan theta equals op over adjacent. Okay, so tan of, now I substitute my values in, 72 degrees equals 30 over x. When x is on the bottom of the ratio, it's a division, so it should be 30 divided by tan 72. And it's going to be 9.75, what was it, meters. Okay, so you are standing 9.75 meters away from the base of the building. So we see that word base again, right? That, or just remember basement, it means it's at the bottom. A tangent is, so last year in Essential 11, if you were in, or wherever you learned your stuff prior to this, you learned for right angle trigonometry, you learned 3 ratios. Sine theta equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse. So wherever your angle was, if this was the angle, if that was the angle you were given to use, this would be called the opposite side to the angle. This would be the adjacent side. The adjacent means right beside. And the side across from the box is always called the hypotenuse. So this was covered in a previous math course. And if you don't remember that, again, maybe tomorrow during work class, you can ask me and I can scare up some old right angle trig stuff for you. All right, last example. You're in charge of designing a wooden ramp to go over a section of heaved concrete. So you know how sometimes the sidewalk, especially when it's really hot and really cold, it heaves up. And so you want to put a ramp over this. The design is shown below. Powered wheelchairs can cross the ramp only if the angle that the ramp makes with the sidewalk is less than 15 degrees. Okay, so this is the sidewalk, right? And a portion of the sidewalk is buckling up, heaving up. Will your design be able to accommodate people in wheelchairs? Justify your answer. Okay, what do we have here? This is the sidewalk. This whole length is 8 meters. And I'm worried about, so I can see it's kind of like an obstructed triangle, right? So I'm just going to redraw my triangle so it looks a little nicer. So I have 147 degrees here. 4.7 meters here, 8 meters here. Okay, I have a complete partnership, right? So this is law of sines because these guys go together. And am I looking for this angle? Yes. The angle that the ramp makes with the sidewalk. So this is the ramp, this is the sidewalk. So I'm looking for this angle, right? So once we figure out what we're solving, I think it becomes pretty clear cut. So I have this perfect partnership, 8 partners with sine of 147, and 4.7 partners with sine of my mystery angle. Okay, so this is a fairly straightforward one now. I multiply, I divide. So sine theta equals 4.7 times sine 147 divided by 8. Now I'm solving for an angle. So remember, this is like a two-step answer. I put everything into my calculator first. Okay, so 4.7 times sine 147 divided by 8 equals, and I get this preliminary answer, right, that I leave in my calculator. And then the very last thing I do, I want to get rid of the sine, right? So I second sine equals. So theta equals 18.66 degrees. Okay, that's my answer for the angle. But it says, let's see. The angle must be less than 15. Is this less than 15? So because the angle, it is greater than 15 degrees, so it is not safe. Okay. Hi, Hadija. I just saw your comment. So that's it for the examples. Let me know if there's Okay, Cynthia, let's go back and look at that calculator. Okay, Hadija, I just emailed something to you, Hadija, if you want to check your email. Cynthia, you want to go back and check that other question then? Okay, so I'm done recording the examples. So I'll post the notes later, and I'm just going to move back to example 6 because there was a student who had a problem with it. So Cynthia, can you try this one again? So in your calculator, punch in 80 squared plus 65 squared minus 2 times 80 times 65 times cos of 20. And let me know what you get. Okay, so you're going to have to type in, let's try this again. So in your calculator, Cynthia, I want you to type in 80 squared plus 65 squared minus 2 times 80 times 65 times, now remember, you're going to have to type in 20 cos. And then you have to press the equal sign. Oops, I'm getting something completely different. Okay, I'm getting something completely different now. So it's a good thing I redid it. Yikes. I'm going to use my better calculator. But you shouldn't be getting a decimal answer like that. It should be a big number. Whoops. Oh man, my fingers aren't working today. Cos 20 equals, okay, so I'm getting a completely different answer. There we go. So 852.196 dot, 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 right? And it's 29.19. Okay. Were you forgetting to press the equal sign, Cynthia? I'm not sure what the problem is, but yeah, you have to put your, you've got to put your cos, your 20, yours backwards all the time. Don't forget that. Okay, sorry. Good thing we went back to do this because I had the wrong answer written down. Okay, so that's it for the live stream today. Hadija, I see you're watching. Nice to see you or see you're chatting. Please check your email, Hadija. And you can check it. If you can check it right now, let me know if you got it. Okay, so that's it for today. If there are no other questions, I am going to sign off. I'll get ready for my next class, and I'm going to have a work class tomorrow. So you can just hop on and hop on the website. I'll have the Google Meet link probably up to tomorrow's blog, so you can just click on there and let me know if you have any questions, okay? And we'll spend the class just kind of working through the problems. All right.